This is chapter 3.4, Proofs with Perpendicular Lines. The distance from a point to a line is the length of the perpendicular segment from the point to the line. So if we have any given point on a plane and we have another line, then the distance from that point to the line is this segment right here that's perpendicular to this line. Given that, find the distance from point A to line BD. I've drawn in some lines here for you, and the distance from point A to line BD is going to be this segment right here that goes until point C and is perpendicular. Now, when I drew this line, I drew that this is a right angle, so we know that this point right here is going to be the distance, and this point at point C is actually a nice coordinate point of 1 and -1. So we don't need to find the slopes or equations of any lines to solve for the distance from point A to point C. If you remember the distance formula, we have distance equals to the square root of our x values. So this point A is -3 and 3. So -3 minus our x value of point C, which is 1, squared, plus the y value of point A minus the y value of point C, which is -1, squared, and solve. -3 minus 1 is -4. -4 squared is 16. 3 minus -1 is +1. 3 plus 1 is 4. 4 squared is another 16. 16 plus 16 is 32. And you can simplify this to 16 times 2, so that's 4 times the square root of 2. And that is the distance from point A to point C, also known as the distance from point A to line BD. Now there's a definition that we're going to learn and also a couple of theorems. The definition is a perpendicular bisector of a line segment PQ is the line N with the following two properties. That N is perpendicular to PQ, and that N passes through the midpoint M of PQ. So again, a perpendicular bisector, we're cutting a segment in half while also maintaining that the segment is perpendicular, so it forms a right angle. Theorem 3.10 is a linear pair perpendicular theorem. So if two lines intersect to form a linear pair of congruent angles, then the lines are perpendicular. Theorem 3.11, perpendicular transversal theorem. In a plane, if a transversal is perpendicular to one of the two parallel lines, then it is also perpendicular to the other line. Theorem 3.12, lines perpendicular to a transversal theorem. In a plane, if two lines are perpendicular to the same line, then they are parallel to each other. Given these theorems, let's do our proof. If we are given that H is parallel to K and J is perpendicular to H, prove that J is perpendicular to K. And I did not draw the picture yet, so let's do that first. We're going to draw line J first as a vertical line, then draw line H as a horizontal line, and another line K as another horizontal line. And label. There's a right angle here. This is angle 1, 2, 3, and 4. And this is angle 5, 6, 7, and 8. In our two column proofs, we have our statements on one side and our reasons on the other side. So we're going to write down our given statements first, is that H is parallel to line K and J is perpendicular to line H. The next thing we know is that the measure of angle 2 is equal to 90 degrees because this is the definition of perpendicular lines. Since they tell us that J, because they give us this little mark right here. That's right. Okay, we also know that angle 2 is congruent to angle 6 because we're given that H and K are parallel lines. And so that means 2 and 6 are also parallel lines because of the corresponding angles theorem. We also know that the measure of angle 2 is equal to the measure of angle 6 because of the definition of congruent angles. Oh wait, that's not a theorem, it's just a definition. Okay. Because we want to change this to comparing their length, or not their length, their degree measurements and not just their congruency. Now using substitution, we can change this measure of angle 2 to 90 degrees. And at the very end, we can prove that J is perpendicular to K because of the definition of perpendicular lines. We just proved that angle 6 is 90 degrees. So if this is 90 degrees, then J and K must be perpendicular. The last problem is example 3. Determine which lines, if any, must be parallel in the diagram. So first of all, we know that angle S, this angle right here with line S and line T are both 90 degrees. So S and T must be parallel. P and Q are also parallel because these are both 90-degree angles as well, which means that these two lines are parallel. And that's it.